All right, let's go ahead and start at least coding up a little bit about a hash table. Let's see, what do we want to do? How would we go about this? What do we want our hash table to be?
Hashy.
Hashy.
Hash browns?
Hash browns. So remember, it's a map. So what are we mapping?
Oh, I already.
Values.
We're mapping two values, but what should be the key? The key. Okay, great. What's an example? You know, you want to map integers to strings?
Whatever the lab does.
Whatever the lab does. The lab makes you template everything.
We should do something in template.
Sure.
In code? In class? Really?
Go ahead and set it up for us, and then we'll do the rest.
Aha.
Yeah.
You want me to actually set up the lab for you, even though the point of the lab is to make you learn how to code correctly.
I mean, we're learning how to code correctly when we watch you.
Yeah,
No.
regardless. We're learning something.
Some people are
regardless.
visual learners.
Some people are visual. Well, that's why I'm typing things on the screen.
Way to go. Captain Obvious.
Hey, y'all ask a silly question, I'll give you a silly answer. No examples, otherwise I'm going to do integers to strings. You're not going to like it.
Social security numbers
All right,
to people's names.
so again, integers to strings?
Yes.
Yeah.
Great. All right. All right, so what's our data structure?
Hash table.
Right, and we're going to compose the hash table of
An array.
an array. So we want a vector. Oh, here, I'll do using namespace std. I'll break from the bold. Vector, what's going to be the vector of?
Integers?
String.
All of the above?
Hash table is an array of,
Integers.
Pointers.
not arrays of arrays, but an array of,
Linked list.
there we go.
Okay.
And what was the STL linked list one? You don't remember? Well, guess what? Neither do I. I believe it's a queue.
No.
Can we get an iterator for this thing? No? Wait, are there no iterators here? There's no iterators. So then the answer is it must be list. Because we're going to have to get a list. I know, it's terrible.
No, it's just something that comes to mind.
Does this, okay, this has an iterator. Great. So we'll use a list.
Did I see Microsoft on an advertisement?
I'm sure it was. So we're going to have a vector of lists of strings. And I'll just call it the hash table. All right. Let's see what we got. We have vector, and then another one for list. And what do we want the default capacity of our hash table to be? We'll make it 100. All right, let's see if we type that correctly.
Probably not.
Why are you so...
Hey,
It's a hashed table. Oh, that's kind of cool. Yes.
About the command line itself, when you do the G++, what version of C++ does it on? 98?
That's a good question.
Because I'm trying to figure out.
So 4.9.2. All right, G++ default C++ version for 4.9.2.
Well,
So supports 98, contains experimental support for 2011. So it probably is using C++ 98 by default.
does it use 03?
Hold on.
Most of the changes, okay.
They're implemented, but they may not. By default, uses some extensions of 03, but not all. There you go. It's really 98. Okay. I think I said HashTable. There we go. G++, HashTable.cpp, and then we'll run it. Let's see if it compiles. Ooh, it compiled. Great. Okay. So, if we want to, let's say, void insert, we'll say integer is the key and the string is the value. That way we can just do insert. What do you want? Like 7, 4. Wait, we're doing Social Security numbers, right?
Yeah.
1, 2, 3, 4, 5, 6, 7, 8, 9. And this will go to good old Bob. What else do we want?
Bob Ross.
Yeah, that.
To which one?
Bob Ross.
By Bob Ross. Alright, what other number do we want? Who's going to be here?
Jeff.
Jeff. Good old Jeff. Okay. So we're going to be able to insert those. Let's see if it compiles. And yeah, it does. Man, we're doing great. Alright, so what's the first thing we need to do?
So these have the value, now we have to insert them.
Doing what?
Now we have to insert them.
Yeah, but we're being passed a value. We need to insert it. I'm inside the insert function. What's the first thing we do inside of insert?
You have to check to make sure it's not there.
Oh, I'm sorry. Check to make sure that is supposed to be what it's supposed to be.
Okay. How do we go about that?
Right?
Well, what the key is an integer from -2 billion to +2 billion. Our array is size 100, so 0 to 99. So what's the first thing we need to do?
Oh, create whatever it is we're inserting into it. Whatever kind of that.
Oh, we already have that. It's being passed in as the value.
So we are agreed that just checking it is
Okay, how do we check it?
make sure that, well, since it's socials, we know how many changes is in the socials, so we have to make sure that it has at least that first.
Okay. How do we find if it's in there?
Sorry?
How do we find if it's in the hash table?
Oh, I see what you're saying now. Jonah? It's all you, man. Right.
It's all you?
Jonah, it's all you. Go ahead. No clue.
Hmm.
Not sure what to say.
Let's see, let's go back. Do we have any insert code in here? We did. Hash value equals hash function of key table sub hash equals item. So what's the first thing we need to do?
Hash value and hash function key.
All right. What is that doing?
Setting the hash value.
It's setting the hash value to the hash function of the key. Cool. Right.
And hash value if you know the hash function key.
But what is the hash function? What does it do?
Hashes.
No, it does not hash. Good guess, though.
Oh, it just combines the whatever. Or, yeah. Am I gonna have the right one here?
Let's go to this picture.
Alright, never mind.
Doesn't it like ensure there's like a spot to put?
Hold on. All right, so if we want to insert 101 in this picture, what's the first thing we do? Do we jump to index 101?
No.
No, what are we doing instead?
Use a hash function
Right, to do what?
to find where it should go.
Okay. And what do we usually use to make that hash function? So we need to, I'll go int position equals hash function of the key. And that'll be the position of the array. Well, you know, that kind of just kicks the can down the road, but that's okay. Int hash function of an int. What is this going to return? because key needs to be from 0 to 99. Didn't I just do this? Didn't we just do this?
Are you modding again?
Yes.
Mod by something.
Mod by 100. All right. Yeah, what happened, guys?
Falling apart right now. What happened?
All right, so that's the position. So we have hash table of position. And that's going to give us what? What does the hash table of a position give us? You're doing a different lab as opposed to learning.
The value.
At least I'm doing something that's
It's true.
plenty of homework to do.
What does that give us? Right
Can we use the size of the hash table, pretty much?
It's what?
Size of the hash table?
No.
No.
The
The
value, right? No?
Well, okay, what is the hash table right here? What is hash table? A vector of?
Vector of.
String.
No.
Vector of list.
I'm so
Linked list.
It's a vector of linked lists, and those linked lists contain strings. So it's a vector of strings. I'm sorry. It's a vector of lists
So
of
it's a
strings.
multi-dimensional vector in a sense.
In a way, two-dimensional. So if I'm going in hash table and I'm jumping to some position, what does that give us? What are we looking? A list of.
Strings.
Right. So if we want to add to a list of strings, we need to go figure out what function we use to add to a list of strings. All right, let's see, what do we do here? Hey, push back or push front. Sure. Dot push back the value. So does that insert it?
Yeah, pushes it to the last.
Mm-hmm. Last value. Okay. Let's see if that compiles.
No.
Oh, it did. How about that? Thanks for your vote of confidence.
We're
All right.
always confident in you.
So let's
What did I make today?
search on a key. On a K? On a key. So if we want, let's say for example, we're down here and we want to go cout 1, 2, 3, 4, 5, 6, 7, 8, 9 has a name of, and then we'll do search on 1, 2, 3, 4, 5, 6, 7, 8, 9. What should that give us? We want this to give us back Bob, right? Because we inserted it. Now we want Bob back. We want Bob back. All right.
Come on back, Bob.
Come on back, Bob. How do we get Bob?
You call them back.
We call him back. All right. We're passing the key. How do we get Bob back?
Why not just use operator brackets?
On what?
Key itself. Or the vector
So
itself.
you're asking me to do keys.
No, M hash table.
Okay, there we go.
Bracket key return. And then you will return that.
All right. Who thinks this is going to work? No one? Let's see what happens. Nothing. What did this just do? Hold on. Stop. What did this just do?
It only gets the first one.
No. Well, what's the key here?
Integer.
An integer. What number is it?
Oh, okay.
And what's the size of my array? 100? Did that... Would Valgrind complain at us about this? Let's find out.
I don't think so.
It didn't. That's kind of cool. Should have. So that's not what we're looking for.
Exceptions, I thought.
Wow, Valgrind, you really didn't... Valgrind should have told you the problem here, but it didn't.
Valgrind, I choose you.
I choose you, Valgrind. Valgrind. Whew, see, I was even calling it the wrong name. Oh well. Alright. Well, that's not getting the right value, but you're on the right track. It's hash table not of the key, but of the what? The position. Okay, so we want to have a position here. Right. So how do we get the position?
function?
Yeah. Okay. Wonder what is that going to give us what we want? What's the HashTable out of function? It's a.
Say that one more time.
What is the HashTable of a position, or of a half of an index? If you go to some index of the HashTable, you have a what? Sorry.
List of strings.
List of strings. So this isn't going to really give us what we want. It's really.
You're trying to get the memory address?
Okay. So we're getting there. Wait.
Are you really getting there though?
Yeah, I'm all out of ideas.
Hold on a second. This is not working the way I want it to. And I just realized why. We're not writing to the correct place. So let's go fix this. Alright, there we go. There we are. Now it's giving us errors like it should. Alright. Now we're having errors. Good old errors. We'll just not return anything, and then we'll go ahead and run it. Oops, that's not what I meant to do. Let's quit. Let's actually run it. Ooh, segfault. Yeah! One who has a name of... Okay. Alright, so it's HashTable of position, and if we try and compile it, we get an error because... What is that? Could not convert HashTable vector blah 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 blah. The problem is...
Basically, it's two different data types.
Right, it's trying to get a string, but I'm actually at a...
Integer.
Nope.
Yeah,
HashTable at a position is a... What is it, Craig?
String.
Just Craig.
String.
Stop. What is the HashTable?
Linked list.
So it's a linked list. Why is this a linked list right here? Come on, Craig. You got this. You can do it.
I honestly don't know.
What is the HashTable? What is the HashTable of? It's a vector of...
Strings.
No, it's a vector of... It's a vector of list of...
Strings.
So it's a vector of...
Strings.
No.
We're gonna
Okay, all right, hold on. Everyone stop. Wow, okay. Whew.
Um,
Read this from left to right.
It's a vector of
No, just read it left to right exactly as it is.
vector,
Yes.
list,
Vector, what's this? Just say of or less than.
less than,
Less than.
list,
Okay.
a linked list, really.
Sure. Yes. Good. Good.
String, less than, string, greater than, and hash table.
All right. Passing in 100 to its. What am I passing 100 to here? It's
Array, or the vector itself.
right. The constructor of the vector. Good. You are on the right track. All right. So let's read it again. From the left, it's a of
Linked lists of strings.
of string. Okay. Great. So if I'm at the hash
So
table,
100
what?
values for the vector itself, which you forgot to add.
What's that?
With 100 allocated 100 spaces that you forgot to add to
Sure. Sure. It has a capacity of 100.
capacity of 100.
Great. So if I'm here and I go HashTable and I jump to position, what do I have?
The whole linked list at that position.
Yeah, right. I have a linked list at that position. So I need to find something, don't I?
Yeah, you need to find.
You need to go in more.
You need the
You
data.
just find the string, or yeah, the string within that linked list.
Right. We need to find the string within that linked list. So here's where the problem comes into play.
Here is where the problem.
Yeah, this is where the real problem comes into play. That's what y'all got to think about. Well, I have a key, and I need to find something in this linked list, this list of strings that matches the key, but I only have strings.
How is that?
Why not the pointer itself? They just guessed it.
Nope. Do you understand the problem here?
Yeah,
Because the linked list is only of
String.
strings, but we're searching by a
Integer.
integer, a key. How can we fix this? I'll give you a hint. It's going to involve changing the insert function. When we insert something, what are we inserting?
You're inserting the integer with the string itself.
Are we actually inserting the integer?
No count.
No, we're just inserting the string.
Okay.
So what else should we be inserting?
The integer.
So how can we do that?
Sorry.
Actually, I like that. I was like, yes, how can we do that? I don't know what's going on. I'm sorry, Jonah. I'm sorry. I didn't mean to. Okay, thank you. Go ahead,
Of
Craig.
course you would do it to me.
That's pretty face. It's all good.
It's all good.
An idea would be, since I did this in my first project, I did a whole linked list. You can have the integer with the string inside the head itself, and then you have the pointer points to the next one. You can implement it that way.
All right. So what you created was a.
A string with the integer itself.
So you created a separate. How would you group those two together? In a.
Linked list. And as the m head.
So the m head pointed to a.
To an integer and a string.
To an integer and a string, as well as to the next item. Right. So how would you group that all together? Easily. We've been using this actually all the time.
Pointers. Alright. I don't know.
We'll use the struct this time. I wonder if that'll work.
Why do I want my grade
So you have a hash node. You know, a node. Have you all seen node before?
Yes.
When have you seen node before?
Fine.
And in linked list, what was the node doing?
Good question.
It was doing the stuff.
It was doing the stuff with the things. What was it holding?
It was holding the data,
Data as well as
the position.
well, not the position, but the pointers to. You had it, Jamie.
The next node.
The next children. So here in a hash, but in a hash node, it would just contain the key and the value pair, right? Yeah, sure. Okay. I just asked y'all to agree with me, and y'all did. So good job.
Woo!
Whew! Dodge that bullet. All right, hash node. Comment that out. We'll say new node. And we'll call it new node dot m key equals key. New node dot m value equals value. Okay. But you know what? I'm skipping ahead here. What do we need to change our hash table to? When Craig, why are you leaving? Why? All right, I will just bug him when he gets back. So it's now, what is it now? We currently have a vector of lists of strings. Now it should be a,
Let's see, where is the node set? It's just inside the list.
say that again?
The node should sit
In here?
inside the list.
All right, so it's actually a vector of lists of
Strings.
nodes.
Or nodes. sorry.
Nodes.
Yeah.
So it's actually 100 of those guys. So when we push back, we actually need to push back our node. So we put the key and the value inside the node, get the position, and then push back the node. Let's see if that compiled, if I typed everything correctly. Nope,
Oh.
not even close. Not a surprise. All right. Whoa. Hash table at position. Hash table. Am I compiling the right function? All right, hang on. Restart this just to make sure I'm clear. Here we go. That makes more sense. mkey, which is of non-class type hash node. Request from member mkey, which of non-class type hash node. Hash node. Am I going crazy?
Yep.
That's what I thought. Don't put the parentheses there unless you absolutely need to. It really confuses C++, as you just saw. So we still have the problem where it's printing out a bunch of segfaults, but it looks like it's actually inserting things. So now, how are we going to implement this part? So we really want to, we're going to search by a key, so we wanted to get a hash node right here and put the key in it. We find the position of the hash node, and now we're going to do what?
You need to return value.
Right, the hash value. When we get to hash table, what's hash table of position? What am I now looking at?
So now you're looking at the nodes inside the list itself.
Right, so I have a list of nodes.
Yes. So they start to look through that.
Right, so we need to see if we can look through that. Let's see, do we have anything in here that will help us? Hey, we can sort them. Relational operators. Insert, swap, resize, clear. Front, back, capacity. See begin. Okay, so we have iterators, so we can iterate through it. Alright, maybe we should iterate through it. So we got begin and end. Okay. Who remembers the iterators?
Like that, no one.
Oh man, I love the face that Joe just gave me. It was like,
like-
oh.
Sure,
Yeah, the thing with the stuff.
Yeah, that's right. That's right.
Totally. I don't even know if this is correct, by the way.
Oh, well.
But it looks great, doesn't it?
Yeah.
It's
That's
beautiful.
so convincing.
It is, isn't it? I know exactly what I'm doing. Alright, let's see if that compiles. Nope.
Good job.
I'm really
Wow.
sad right now. Wow, C++. Alright, here we go. I misspelled begin. That was the error. Let's try this again.
Nope, not the only error.
Well, not the only error. That's true. Oh my goodness. Who created this language? Actually, I know who it was. Alright, here we go. Conversion from to non-scalar What? Oh. Because an iterator has to be a pointer. An iterator's a pointer.
Oh, it's a limit.
Can I pipe that to less? No. It's so annoying. Oh my goodness. Okay, here we go. Cannot convert to... Wait, what's the difference?
It just doesn't like you.
Standard vector... Oh. That's because it's actually in HashTable subposition dot begin. Same thing with the end. Because you want to go to that actual list. I'm so sad. I'm using this language. Okay, here we go. Alright, now cannot convert list iterator to iterator. Does it really not want the star anymore? That might be the problem.
Whoa.
Yep, that was good.
Matrix.
It did it. That was it. That was the error. I fixed it. It was the matrix.
Whoa.
Alright, so here's the iterator. As you can see,
Oh, just that.
sometimes trying to make your iterators work correctly is
Not fun.
not fun, but such is life.
Like this one. That's what we learned here today.
Alright, so I have the iterator. How do I check each element in the iterator?
Yeah, yeah.
How did we do that? Just check if the two keys are there. Check if the iterator's key is equal to the key being passed in. And if it is, what does that mean?
You're at
Then,
the
then
right
you
one.
need to, then you're where you need to be.
Alright, and then we need to return what?
The value.
That's that.
Yeah. And if all else fails, we'll just return null. And this is C++. Alright, let's see what happens now. Oh! It worked! Ship it!
Should you run more than one test case to make sure it works?
Runs one test case, it's ready to ship.
That's how Microsoft works, right?
I didn't say it this
Every
time.
time they update, they did a new test case.
We are.
There we're up to 10.
Okay. So I've done search, I've done insert. What do you think I'm not going to do?
Yeah.
Delete.
Delete.
Yeah.
Right.
Just destroy the
Uh-oh.
Just delete the program.
whole thing. We need to remove one value, just destroy the whole list.
Don't remove Bob Ross though.
It
He
must
created
be
too many
done.
good works of art.
Uh-huh. Well, let's see if actually let's see if this works better, or for our other items. We only have one test case. Is that a good test case? Just destroy the whole thing. Yeah, I agree. What should this return?
Bob Ross.
Something. No Bob Ross. And then what should this return?
Jeff.
Hey, hey, worky. Look at
Why
that.
are they all guys' names?
Because we're sexist? I don't know. You want some female names in there?
Sure.
Alright. Actually, let's take this to the next level.
Make sure it's gender neutral.
Gender neutral.
Oh.
1,000? Put in a million.
Hey, hey.
Alright, here we go.
Wait, you need to change.
Oh no.
Are you starting to use that now?
Oh no.
What?
This is gonna be very good.
This is gonna be bad? How bad could this possibly
Don't
be?
you need to also change like the whole like percent thing to that number?
Now we'll get to that. Hang
I don't know
on.
why.
So we're gonna do srand.
You should make a size variable.
Whoops. I should make a size. Oh, define it up top.
Yeah.
Would this really make you better, happier? Define size as well. How's that?
Sure.
Good. I'm glad we had this discussion.
Are you really though?
Oh, I'm happy.
What?
Oh, I'm happy.
You like happy feet.
So m HashTable dot insert. We'll go rand. Is that how you use rand here? I don't even remember anymore. Oh, that was not what I wanted. So like, is it man 2 rand? Or is it man 3 rand? There we go. Nope, just man rand. Excellent. No. Some random integer. Oh, we need to have a string. Hmm?
What if you take a string from that file of names that we have for Project One?
Ooh. That'd be nice. Nah, let's not do that.
Worth a shot.
It was. Oops. Equals I. There we go. Let's see if that works. See if we can insert all those things in here. Let's see if that compiles. Not quite.
Nope.
It doesn't understand what size. Wait, hold on. We have other errors.
Size wasn't in that one.
Error.
You didn't put size in there.
I put a semicolon.
And that's also.
There we go. srand not declared. What is it? What is srand member of? Oh, standard lib.
I hope you didn't include the library.
That's I hate that. You fix one, 10 more pop up.
All right.
The life of a coder.
No matching function call for bloop. Really? Really? Really?
Did you spell something wrong again?
No, it just wants me to put I right here.
That's annoying.
I agree completely. Or maybe it wants me to do something completely different. Here we go. Alright, no matching function call for... Oh, you've got to be kidding me. Alright. We'll go do it your way. Passing value. Then we'll go up here, and we'll go and do search by reference. Alright. No matching function called to integer std string. Oh, that's because it's not actually part of the hash table. There we go. Oh, it completed. There, that was it. Everyone happy now?
No.
No? Okay, good. That's fine. I'm going to stop passing this by reference because that's just silly in this regard. Excellent, yeah. Alright, so that's how long it took to insert. What?
Dang it, printer.
Let's see. Keys, sub, size. That's annoying. Keys of size. That way we can actually store what all our keys are. Key sub I equals rand. And then that way we'll just pass that in here. AKA, I'm keeping track of all my keys, right? Keep track of my
Oh, yeah.
random keys. Insert into hash table. Alright. So if I were to go create another for loop from 1, 0 to size, and I were to do search on, I don't know, key sub I, what should this always equal? Well, it should always equal value, right?
Yes.
So if it doesn't equal, we have a problem. And I'm going to use printf here because I'm tired of cout. Search of %d equals %s,
What is %d?
but should integer, but should be %s. So d here is key sub I. The actual value is equals search sub key sub I dot c underscore str, and then it's value dot c underscore str. There we go. I didn't like it. Key not declared in the scope. That's because it's keys.
You didn't do a couple more
Yeah.
times.
I did.
Search.
Printf was not declared in the scope. Are you serious?
Oh, do it again. Why do you not like S's?
I don't know.
What?
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 It's not quite working well.
No.
What does this mean?
Would it be funny to
What
make
did
the
you
last
do?
one?
I don't really know. What did I do?
Seems like I almost want to say it's infinite,
Let's say it's infinite.
No, it's just
but it's not much fun code.
Maybe we want to be like this. And let's go and put some single quotes around it so we can actually see what's going on. Alright, now let's run it. Segfault! That was beautiful.
Why'd you put a period there?
So it'd be a sentence? Or do you not like sentences?
Eh.
Let's see where our segfault is. Bet you I know where it is. Nope, I don't. Wow, it's really giving me nothing here. Operator equals constant char. Really? That's the problem? Alright. We'll get rid of that then.
They didn't like it.
I didn't like it. So we have A to I. Do we have I to A? Let's see if we have that.
Where did they come from?
Right here. No entry. Okay, let's see how you do it. C++ convert integer to string. Let's see how we do that. Converting
I know
numbers.
what you spelled.
Huh?
Virgin integer, right?
Virgin.
Everyone's a critic.
Strings.
I have to make an S stream?
Yeah.
String stream, you mean?
Really?
Static caps.
My favorite
What is
string
that?
strings.
What?
Alright,
Welcome
see.
to C++ 98.
Who wrote this thing?
This is the
Thank you for joining us.
Alright, fine. We'll create our O string stream O string. Oh, this is really kind of frustrating now.
yeah, it is.
O string. Who wrote this language? I
Some dumb guy.
I did.
O string dot. Don't I have to do something else?
Yeah.
Dot str. Let's see what that does. Or is it going to fail miserably? Oops, that's not what I wanted.
Uh-oh.
No, it's good. Wait, or it could be terribly, terribly bad.
I think it's bad.
Yeah.
I think it's very, very
Oh, it is very bad. My machine kind of froze for a moment there. Let's put size down a little.
That sounds good. That.
Oh my
god.
That is a very big number.
That single butt should be.
All right, we never actually cleared this, so let's do that. Is it clear? I hope so.
Nope. No, it is flush.
How do you clear?
Flush.
How do you clear?
Flush.
Is it flush?
There's, I mean, we talked about flush. But
Oh, that's right. You do need to flush. No, it's not flushing. Okay. Now we got to find out how you clear the thingy with the stuff.
pick up the stuff.
Stream clear. How do you clear an O stream string? Thank you, Stack Overflow.
Clear.
That didn't do it. Oh, you have to. Okay. So it's two things. First. There we go. So then when we're down here, we do the same thing. Who wrote this language? Oh my goodness. Okay, well that was nice and confusing.
Oh, good for
Oh my goodness. Good. That means it ran correctly. Let's go ahead and increase the size. And you know what else we should do? We should probably turn on optimizations. Bum 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 bum.
It did one.
Hey, one of them's wrong. I wonder what we did wrong. Any guesses? None? No guesses?
I have a feeling it's an off by one something.
Off by one error. Well, at least it's the same thing.
It just doesn't make sense.
Okay, well, let's see if we can diagnose this a little more. What if we do, we'll leave C out this time since it's being a pain. Let's see. HashTable sub hash function of the key sub I dot size. See what the size is. The size is 957. Wow,
Why?
that's pretty big. That's a good question. Let's see what all the other sizes are.
That
Something's not right here.
is not right at all.
This hash table is too. Shouldn't the hash table be of a certain size? Let's find out.
That would make sense.
That would make sense. I think we're not using vector correctly.
Yep.
Let's find out.
Just have been doing everything wrong today.
Oh, I hope so. Constructor constructed the vector. Why is this website so slow? Oh, there's nothing in it. Wait, we've been using the constructor the wrong way the whole time. Awesome. So we want to do, where's capacity? Is there a set size? Request a change in capacity. There we go. So we actually need to change the capacity. And that is, there we go. So we create the hash table, then the first thing in our function we need to do is mHashTable.resize with the new size that we want. And then that should do it. That did not do it. Reserve. Segfault.
Good job.
Oh, this is getting better and better. You understand why I don't use the STL too often?
Because it's icky.
Yeah, it's actually kind of a pain. It's in insert. The key and the value is 0. Line 29. 29. Why is that a segfault? Hash function. Oh, percent 100? Shouldn't that be a percent size? Yes.
Didn't we say that earlier?
Yes.
Yeah,
Yeah.
because I did.
Yeah. Still segfaulting. Probably on the same part.
No stack.
Because I haven't run it yet. Alright, what do we got here? Push back. Insert this key at this value. Line 29. It just does not like it. It's saying that the hash table position is not correct. That doesn't make any sense.
I guess
So
we don't need to learn hash tables.
we'll go and do it my way. Just to see if that's going to help it any. We'll find out. Okay. Now it's actually working properly.
Are you sure?
No. Why would I ever be sure of this?
That's good.
Okay, here we go. And the size is 4.
That's interesting.
It is interesting. Maybe we should print out all the elements of it. How's that sound?
Sure.
Why not, right?
Answer to everything.
It's a chain. It'll be equal to whatever's at this position. That's the answer to everything. Let's go and copy paste our amazing iterator. Oops. 1, 2, 3, 4. Alright. And inside of here, I's iterator actually going to be of the chain to the end of the chain. So we want to see out basically I ooh, key, comma, I value, and I'll put out space, and then after that we'll just give it a good old new line. Didn't like that. M key, M value. There we go. Okay, so is this even in the list? Search equals, but that's the correct answer. Oh. Oh.
Oh.
What's the problem here?
A lot of
Is our hash table actually operating correctly?
No.
This is going to be a great thing for y'all to answer. I'm going to sit back here and let y'all look at it. What am I printing out right here? I'm going to go, I'll make it a little clearer here.
the key and the value.
All right, printing out the contents of the chain at m hash table sub, and what do we got? Hash function. So keys. Oops. We'll just say keys sub I. What just happened here? Didn't like something. Key sub I, printing out. Oh, what was there? No match for operator subscript. What?
Oh, it's key. No?
No, I spelled it correctly, didn't I? Oh, because key is I here. Oh, I have different I's. Uh-oh. Because I called the iterator here I, so of course it's not going to have it here. So I need to say int index equals I. Because I have a scoping issue. There, I fixed the scoping issue real quick. That right here. Now it makes more sense. Okay. So it's saying that the search, I'll go ahead and clear this real quick, a.out. So the search of this key returned this value, but it recorded that the value should have been this. Okay? Printing out the contents of the chain located at m hash table sub blah blah blah. So this is the chain. First element is this key, matching to that value. Second one is this key, matching to that value. Third one is this key, matching to that value. And the final one is this key, matching to that value. What's going on?
There's two key values.
Yeah.
There's
Two
oh
that
no.
are the same.
Okay, because there's 4 key values.
There's two that are the same.
They're not. None of these are perfectly the same. There are 2 that have the same key.
Yeah.
Was that supposed to happen?
No.
No.
That
So, which is incorrect? Or who's incorrect? I'll give you a hint. This is a trick question.
Neither of them. Because technically you can have 2 to 1 key.
Is our hash table implementation incorrect, or is the usage of our hash table incorrect?
Well,
Both. Okay. Why do you say both?
because I don't know. I just thought because you're doing like how we set it up. We didn't set it up to check if the key value was already used.
So if it's already used, what should we do? Should we replace it or throw an error?
Throw an error.
We could throw an error or replace it. It depends on your hash table implementation. In general, we're going to go ahead and do it the standard way, which is if you already have it, replace it. Which unfortunately means that our test cases are actually incorrect because we're already, we have 2 things going to the same key. And in actuality, our implementation is working correctly. So I'm going to stop here and just say that this way of doing it is actually just fine. You could do .contains and replace it, and that would be okay. You could do it that way inside your hash table with chaining. Or you could just leave it like this, and that'll be okay as well, unless we tried to delete it afterwards, which would not be okay.
But for the lab, are you going to be checking to see if there are two, like,
For the lab, ooh, let's look at the lab.
yeah.
All right, let's stop with the lab, because it is actually specified there. If not, I will tell you what it is. Hang on.